Hello, welcome back. Today's lesson is on 8.6, solving log equations. Before I start to solve the log equation, I just want to remind everyone about one of the facts that we talk about it on a video for the 8.3, one of the facts. And one of the facts that we talk about is that when you have a log with the base b of some number, so if this number is a negative equal to the a, that this means we have no solutions, because think about this turning into an exponential form. So you will have a b to the exponents of a, and that term can never be equal to a negative number. Okay, even if the exponent is a negative, the negative exponent just giving you a fraction, but that will never turn into a negative number. So this is something that we always have to keep in mind when we are trying to solve for the log equations. Okay, that is very, very important. So for example, in the first example on the worksheet, so we want to make sure that when you have a log 3 bracket x minus 4, so this term here cannot be a negative number. If this term turn into a negative, that means the entire expressions will be not possible, will be invalid. Okay, so that's why whenever we're trying to solve for the log equation, we always have to look at what are we trying to solve for, and then we bring it back to the original question to make sure that the original question itself is a valid question. Okay, so let's start with the example number 1a. So when you have a log 3 x minus 4 equal to 2 log 3 and 4. Now remember that you can equate two sides when they are having the same base. So when you have a log 3 over here and you have a log 3 over there, so I can rewrite this as so this one will be a log 3 4, but the multiply the 2, you just have to bring it inside like this. So now we have a log 3 of one term equal to a log 3 of another terms. So when they are the same base, so you can say that this must be equal to that. So therefore, I can say that x minus 4 must be equal to 4 to the power of 2. Okay, so solving for x, so you're going to take the 16 plus the 4. So finally, x must be equal to 20. So that will be my final answer for this one. And as soon as I have the solutions for the x, then I'm going to bring it back to my original questions, and to make sure that when I sub in the x with the 20, does that make this term turn into negative? If the answer is yes, then this one will not be your solutions. Okay, but in this case, it's good. So this one is a good solutions to go. All right. So for part B, when you have a 5 minus a log 4x equal to 3, so again, you don't see any number beside the log. That means this is in base 10. But because the x is inside, so that makes the log 4x becomes the variable term. So we need to isolate the variable term. So I will have to bring the 3 over. So 5 minus the 3 equal to positive log 4x. Okay, we want to make sure that the variable term is positive so we can solve for the x. Okay, so now that means we will have a 2 equal to a log 4x. Now there are two different ways that you can solve for the x here. So the very first way is we can because on the left side there's this one is not in a log form, so we can do it in the exponential form. So think about that this question has the base of 10, so that means the base of 10 to the exponents of a 2 must be equal to 4x. Okay, if you turn this into the exponential form, this is what you get. So now you can solve for the, so 100 divided by the 4 will give you the x. So therefore, x must be equal to 25. Okay, so this will be the solutions for x. And again, quickly, I'm going to bring the 25 back to the original question to make sure that this term here does not turn into a negative. Okay, so this should be a good solution. All right, now so another ways that I want to show you, instead of using the exponential methods, I can also show you that using the log methods too. You see how the left side here equal to 2. So initially I said, well, because 2 is not in the log form, so that's the reason why I'm using this, the exponential form to solve for the x. But if I can make the 2 here into the same log form, so how can I make the 2 into a log form with the base 10? Well, then just think about if I'm going to make this into a log, okay, if this one is base 10, then this one has to be base 10. If this is a base 10, if I have a 10 to the exponents of 2, doesn't that is equal to 2? So so therefore, the other method that I was going to show you is that I'm going to change log 10 to equal to log 4x. Okay, because this part, when I evaluate this part, log 10 2, my answer is going to be equal to 2. But now when I have a log 10 2 here and a log 4x here, so that means this must be equal to that. So therefore, 10 to the power of 2 must be equal to 4x. So we ended up with the same step as what we do with the exponential method. Okay, so solving, so again, 100 divided by 4, you get an x, so x is equal to 24. You still get the same answer. Okay, you still get the same answer, but it just the way how you treat the question differently. The first way, we just, from here, we turn everything into exponential form from this line. But instead of turning this into an exponential form, I'm going to turn the constant 2 into a log with the same base 10, but with the 10 to the power of 2, because a log x will equal to x, right? So this is one of the other facts that we learned from before. Okay, now so for part C, let me just move this down a little bit. Okay, when you're solving for log x, 24 equal to 2. So again, the first methods that we you can certainly use the exponential method. So you have a base of x to the power of 2, okay, is equal to 24. So now just think about to solve for the x, you have to square both sides. So when you square both sides, you get this plus and a minus of root 24, and then x must be equal to, fully simplify, you get a 2 root 6, okay? 4 times 6 give you 25. Now, because x is the base, and the base has to be greater than 0, has to be greater than 1, in fact, not just greater than 0. Any base in the exponential form has to be greater than 1. So therefore, the only valid solutions will be the positive 2 root 6. We cannot take the negative 2 root 6. Okay? We cannot take that. So this will be the solutions, and I just want to remind that since the base has to be greater than 1. Okay? So therefore, we cannot take the negative number. Okay? Now for part D, when you have a log 36, square root of x squared plus 5x is equal to 1/2. So again, if I'm doing the exponential methods, I'm taking the base of 36 to the exponents of 1/2. That I should be getting the square root of x squared plus 5x. Okay, so now the square root of 36 will be 6. okay? And in fact, because this one is also to the exponents of half, so I can say what goes inside must be the same. So I don't even have to square root that, because that is the same as a square root of 36, right? So when you have a square root of one thing and the square root of the other things, then therefore I can say 36 must be equal to x squared plus the 5x. Okay? So when you rearrange everything, so this becomes a simple trinomial. Okay, equal to 0. So you can factor this. And this is going to equal to x plus the 9, x minus the 4. So x is equal to negative 9, or x is equal to 4. Okay? Now, are they all good solutions? Well, let's see. If I'm taking the negative 9, so I got 81 here and minus 45. So I will be getting a positive answer. Okay, so this one is good. And if I put in a 4, definitely this is going to be a positive. So they're both good solutions. So all you have to do is take it, substitute, okay, back from to the original equation to make sure that this c term here cannot be equal to a negative. Okay, so that is D. And finally, 1e, I have a log 3 x minus 4 minus a log 3x equal to negative 2. So remember the law. Whenever you have the same base, log 3 and log 3, okay, but subtraction, so that means this is going to be, I can combine them. So log 3, but I have x minus the 4 over x is going to be equal to negative 2. So again, for this particular question, I can use the exponential method. So I have the base of 3 to the exponents of a negative 2. That is equal to x minus 4 over x. Okay, and then this becomes a 1 over 9 equal to x minus 4 over x. And when you cross multiply, now because you get one fraction here and the other fractions there, so you can cross multiply, so you get x equal to a 9x minus 36. Okay, and rearrange everything, so you will get 8x, that's equal to 36, and x is equal to 36 over 8, which is equal to, reduce it to 9 over 2. Okay, and 9 over 2 is approximately 4.5. So if you think about, if you put in a 4.5 here, you still get a positive. If you get a 4.5 here, you still get a positive. So it will be working out fine. Okay, so this is example 1e. Now, I just want to quickly show you the next example, example 2a. And example 2a, you have a 3 log x equal to log 40 minus a log 5. So again, so some of those questions, it will involve the law. Okay, it will involve the law. So just make sure that, but before you do that, make sure that any multiply, you will use the power law to make sure that you have a log x to the power of 3, okay, and then equal to, now when they're both with the base of 10, so minus means you can combine them as a fraction, so it's 40 divided by 5. So because they're both in the same base, so I can say this must be equal to that. Okay, so x to the power of 3 must be equal to 8. And the cube roots of some number equal to 8, then that number must be equal to 2. Okay, so again, very quickly you're going to plug in the the 2 there, and if you sometimes for this kind of questions, when you're doing the check, when you're trying to do the check, you can see the left side you have a log x 3. So that means if you have a log of a 2 to the power of 3, so that means you have a log of 8. And that will be the same as the right hand side, because the right hand side you have the log of 40 over 5, which is also the log of 8. Okay, so that means this solution is a good one. Okay, now the next one is 2 log x equal to log 15 minus a log 60. So same thing, we're going to do a log x to the power of 2. So I'm bringing the multiplier inside, equal to a log, and now you have a 15 divided by 60. Okay, so so that means now you have this x squared, same as that. So x squared is equal to 15 divided by 60. When you reduce it, you get 1 over 4. So when you square both sides, you get plus and a minus is 1 over 2. Okay, because so now you take a look at it. If x becomes 1/2, that's fine, but when the x is equal to negative 1/2, then it's not okay. So therefore, only x equal to positive 1/2 will be the good solutions. Okay, well, we don't even need to check about that, but it is important that you always take a final look at the end, that you will have you don't have anything negative beside. Okay, so that's very important. The next one, the C, when you have a log x plus a log x minus 1 equal to log 12. So again, because this is a plus, so that means you can combine them as a log x times the x minus 1, okay, equal to log 12. So again, and that means they're both in the base of 10. So I can certainly combine this. So x squared minus x is going to be equal to 12. So rearranging everything as a simple trinomial, and you will get x minus 4 and then x plus the 3. Okay, so you will end up with x equal to positive 4 and x equal to minus 3. Now, because x is part of the term, when you plug in the 4, which is fine, but when you plug in a negative 3, then it's not good. So therefore, the final answer, x has to be equal to 4 only. Okay, so not this one. The negative will not be a valid solutions. And finally, on 2D, so 2D, when you have a log 2 of bracket log x equal to 2, so think about this as in the exponential form. I'm going to take 2 to the power of 2. That will give me the log x. Okay, so that means I have 4 equal to log x. So either you do it the exponential way. Okay, the exponential way is that with the base 10 to the exponents of 4 is equal to 4 is equal to x. So x must be equal to 10,000. Okay, or you can look at this from this step. You can make the 4 into a log with the base 10, but it's a 10 to the 4. That will also give you 4 log x. So again, 10 to the 4 is equal to the x. So x is going to be equal to the same answer as well, but it's just using a different methods to deal with it. Okay?